All right, students, let's move on to the next part of our lesson. Now, we're going to go back to a page that we had previously skipped after doing or finishing off 12A, I think it was, for the notes. So we're going to go back here. Now, this part is going to be helpful for the next chapter and also for 5I, as there's principles in here that apply to both. So what we're going to look into is using your inverse matrices, which we had just learnt before about, to solve matrix equations. Okay, so to solve using your inverse, all right, to solve equations basically. Now, what it says here, multiplying an inverse matrix is useful when we need to undo a matrix multiplication. Now, the easiest way I can sort of explain that to you guys is, let's just go back to some basic algebra and the inverse operations that we learned about. So remember, if you have plus, the inverse is minus. If you have minus, the inverse is plus. If you have multiply, the inverse is divide. And if you have divide, the inverse is multiply. Okay, these are the basic inverse operations that we've learned about previously. Now, when we have an equation, let's say for example, 3x equals 12. Okay, here we need to use inverse operations in order to solve or undo the equation to find out what x is. Okay, so if we're trying to figure out what x is, we need to isolate x by removing that 3. Okay, so that's a 3 times x. Now the inverse of times is divide right there. So in order to get rid of that 3, we're going to divide by 3 here and bring it over here to also divide by 3. And what that gives us is x is equal to 4. So what we've essentially done is we've undone or solved to find out what x is. And that's the basic principle of what this part of the notes is talking about. Undoing a matrix, okay, to find out what unknown variables might be for an equation. Now, remember, when it comes to moving a matrix, you need to make sure you've understood the previous chapter, because we don't just merely multiply or divide a matrix to find an unknown, okay, which is which is basically the principle behind inverses. Okay, we have to inverse a matrix, not just multiply and divide it. So you got to find the inverse of a matrix first before you can really do anything. Okay, so let's move on. If we have this equation, ax equals b, we can solve x by me pre-multiplying the inverse of a. So again, there's that keyword of inverse. So before you actually do anything, find the inverse of the matrix. Then in this case, we're pre-multiplying. Now, what does that mean? Notice how here you've got a and you've got x, okay? And in order to solve for x, we have to pre-multiply. When it says pre-multiply, what we're looking at is the position of that A matrix. See how it's before the x? So if this is your unknown, and A is the thing that you got to get rid of or find the inverse of, we're isolating that x, so we're moving that A. Okay, so this A gets moved, okay, using the inverse, and we're bringing it here, and we're pre-multiplying. So now, what it becomes is, if you look here, A times x equals b. We're isolating the x, okay, or we're trying to figure out what x is. So in order to get rid of that A, okay, we have to multiply it, that A, with its inverse. See that? So remember, you have to find the inverse of a matrix before you work with it. And then you also got to bring it to the other side and pre-multiply it. So see how it's before that b? So that's what it means by pre-multiplying. It's got to be in front. Now, it'll be different if it was b times a inverse. That'll be post-multiply. Okay, so make sure you watch out for where the unknown is, or where that matrix with the inverse is. So if it's before the unknown, so if that's your unknown, that's the matrix. You got to bring it to the other side, pre-multiply it, so put it in that exact position before the b, and inverse. So A inverse times the b. And it's the same principle, like I said, if it's post-multiply. So if the unknown is on the left-hand side and the matrix is on the right, you got to make sure, as you can see here, it's A times its inverse. So if that's A, matrix A, and that's its inverse version, you have to post-multiply when you bring it to the other side. See, what this does is when you multiply them, they cancel each other out, because remember, A, or a matrix times its inverse, will give you its identity matrix, which basically cancels it or brings it back to if you remember identity matrices, which is that. Essentially the same as multiplying a matrix by 1, if you want to simplify it that way. Okay, but you're essentially, again, for this, watching out for the location of the unknown and the matrix. So if your A matrix is on the left-hand side of the unknown, then when you bring it to the other side and you inverse it, it's pre-multiply. So it's got to be A inverse times B. But if your A, so if your unknown's on the left and your A matrix is on the right, when you bring it to the other side, you have to post-multiply. So it has to be B times A inverse. All right, so let's try and do these examples to put to practice what I've been talking about here. So in this example, matrix A is going to be this matrix, and matrix B will be this matrix. Now, according to question A, it says if B is equal to A times X, use multiplication by an inverse to find matrix X. So in this case, X is the unknown matrix. And notice how the matrix of A is on the left-hand side. So with this question, we are pre-multiplying to figure out what X is. So when we move A inverse to the other side, you've got to make sure that it becomes A inverse on the left-hand side times B to figure out X. So let's work that out. A, for question A, B equals A times X. So remember with these questions, okay, it's not just a matter of dividing that A and then dividing it here as well to figure out what X is. Okay, you have to use the inverse of a matrix to get rid of it. So in this case, you're going to multiply that A with an inverse. It's going to be A inverse times A to get rid of it. Because remember, if you multiply a matrix with its inverse version, it cancels itself out. Okay, and remember again of the location of that matrix, it's on the left, so it's going to be pre-multiplying. Okay, so it's going to be A inverse times B matrix equals X. Okay, and that's how we work out what X is going to be. So let's figure it out. Just by now, we've got our form of what we need to do to figure out what X is. So we're just going to replace the letters with the matrices. So matrix A is there. So you've got 1, 3, 2, -1. And then times matrix B. Give yourself space when you do this. Yeah, so 1, -8, 2 is equal to matrix X. So we're trying to figure out what X is. So all we're doing, oh, I forgot. Make sure you put the inverse there, yeah? It's A inverse. So don't forget that inverse. All right, so what we're doing here is we're trying to figure out what X is. So let's get our CAS calculator out. I would have done it here already, but that's matrix A. I've already done it. And that's matrix B. So what we're doing is A inverse times B. So A to the power of -1 times B matrix. And there it is, -3, 1, 2, 0. So matrix X is equal to -3, 1, 2, 0. That's basically it. That's all you've got to do for these sorts of questions. Okay, let's try B. So in B, notice the difference because of in this first question here for A, we were doing pre-multiplication. In B, you'll notice that if it's the other way around, it won't be the same answer. So if it's post-multiplication on this for the other question, it won't be the same. All right, so for B, it's B equals Y times A. And what we're looking for is Y. So if Y, look at Y, it's on this side. The A, okay, is going to be post-multiplying. So it's after. So it's going to be on this side of that B. So if I was to get rid of that A, okay, I have to multiply it with its inverse self. Okay, because that cancels itself out. And then you multiply it here as well. Because I'm trying to find Y. Okay, so now that it's cancelled itself out, Y matrix is going to be B times A inverse. Let me give myself space. Equals Y. Okay, so let's replace the letters with the matrices there. So you've got B matrix, which is 3, 1, -8, 2, times A matrix, which will be 1, 3, 2, -1. But remember, the A matrix has been inversed here. It's equal to Y. So now that's going to give us Y matrix. So Y is equal to my calculator. So look what I've done. It's going to be B times A inverse. It's going to be B matrix times A inverse. So A to the power of -1. And like I said, look how the answers are different. Okay, you've got 5/7, 8/7, -4, 7, and 26. It's different to X matrix there. Okay, so let's write our answer down. It's, what was it? 5/7, 8/7, -2/7, and -26/7. So you can change that to a decimal if you want, but the numbers are going to be a bit wild, so prefer to just use the fractions. All right, so that principle is going to be very important as we move on to the next part, which is going to be 12b. So solving simultaneous linear equations using matrices. So you need to be able to solve equations using matrices for this. All right, let's do it. And remember the previous principles that we just learned. Okay, you'll need to know how to do that, to do this. But the steps is basically the same. So you've got to get your matrix, inverse it, and bring it to the other side, and then multiply it. That's all it is. All right, let's go through this. So a pair of simultaneous linear equations with two unknowns, x and y, is a pair of equations that can be written in this form. So we haven't really done simultaneous equations before in year 10, I believe, or at least for some of the topics. But in this topic, we're just going to learn how to solve them. So we're not going to be drawing them or anything like that, just solving what unknowns are going to be. So two equations, simultaneous, and finding the unknowns. Okay, now what this is saying is this is the form that you'll normally find most simultaneous equations. Okay, so ax plus by. Notice the unknowns here are going to be x and y. Okay, and the letters in actual questions are going to be, so the letters in front of the pronumerals are going to be numbers. Okay, so whatever the number might be. And then here is the answer to those equations, or the equals of those equations. Now, some things to remember with some simultaneous equations, just remember that if you have a letter by itself, there is an invisible one in front. So that doesn't mean 0, okay? There's actually a 1 in front, it's just not written, okay? All right, so let's do this. So in every simultaneous equations, x and y are the things that you're looking for. Also, FYI, sometimes you might have 3 equations that you need to work with. But generally speaking, for simultaneous equations, you're looking for what is the value of x and y in these. And they have to be the same. So in this case, the solution is going to be x equals 2 and y equals 1. Okay? And let's prove that that's the case. Okay, x is 2, y is 1. So if I change x to 2 in this equation, so it's going to be 2 plus, and change y to 1, 2 times 1 equals 4. Does this equation make sense? Well, 2 times 1 is 2, 2 plus 2 is 4. So that actually makes sense that x is 2 and y is 1 for that equation. Let's try it for the other one. So remember, x is 2, so 2 times 2, 2x means 2 times 2. Take away 3 times 1, which equals 1. Okay, let's solve that. So 2 times 2 is 4. Okay, take away 3 times 1 is 3. Does 4 minus 1 equals 1? Yes, it does. So it's correct in saying that x is 2 and y is 1. So how do we get what x is and what y is in this equation using matrices? Okay, that's what we're going to learn about today. All right, so generally when you do these questions, you got to make sure that you understand that your matrices have to be square matrices. Okay, so that's the first thing you have to remember. When we do simultaneous equations, so when we represent simultaneous equations, remember that they're going to be square matrices. Okay, and what you will generally be doing is you'll have a question like this, where it's got obviously the numbers, and you need to represent it into a matrix like this. The way that I like to explain it is you've got three matrices that you're working with. Okay, the first matrix, I call it the number matrix, okay, because you've isolated the numbers or the numbers before the pronumerals, and you've put them all in their own matrix here. So the first matrix you've got to make is, I'll just call it the number matrix. Okay, I'll call it that. Now, it's not the official name, but I just like to say that that's the case. Okay, so you got to make sure you split your matrices into three types. The number matrix. The second type is the letter matrix. Okay, one thing you'll find with the letter matrix is it's always a column matrix, and it's just got all the letters of the unknowns that you're looking for. Okay, so that's pretty straightforward. Say, for example, in most questions, you're going to have two unknowns, x and y. So that's what goes in your letter matrix. So these numbers, firstly, you've got the number matrix. Okay, and they all go in that matrix. And then you've got the letter matrix. So you don't have to do a column of 4 numbers in your letter matrix. It's just whatever the unknowns are, which in this case there's 2. And the last matrix that you got to have is the answer matrix, or I'm going to call it the answer matrix. Now, this isn't the answer. When I'm saying the answer matrix, it's just whatever the numbers are at the other side of the equal sign, and that's what goes here. Okay, you're splitting them up into 3 matrices. Okay, and in between here, you've got to multiply. Okay, so that should give you a clue of what you need to do, because it's quite similar to what I taught you previously, in that in order to figure out what x and y is, have a think, what do you need to do with this matrix? Find its inverse, bring it here, multiply the inverse with this matrix, and that will give you your answer. Okay. Now, there's a more concise way, if you want to look at it, of representing what I just talked about, but essentially, number matrix, letter matrix, answer matrix. That's what you're going to split your equations into. Just some things to be aware, and you'll see this in the next few examples. You can have 3 unknowns. Okay, it'll come about. And also, sometimes you might have an equation where one of the equations, so you've got an equation that's got maybe 2 unknowns, but then one of the equations has only 1 unknown. Okay, if that's the case, we'll need to write a 0 in our number matrix. And I'll show you what that means as we go through. Okay, so let's do this. Represent the following simultaneous equations in a matrix form. So AX equals C. We're going to ignore this for now, because we're going to actually redo these equations anyway here, and we'll solve them. So let's represent these. So remember, there's 3 things you've got to turn this into, or you've got to split it up into: the number matrix, the letter matrix, and the answer matrix. So in the form of AX plus C, so A will represent the number matrix times X, which is the letter matrix, equals C, which is going to be the answer matrix. So let's split that up. So for matrix A, it's the numbers in front of the pronumerals. So the numbers I'm looking at are 2, 3, 6, and negative 5. Those are the numbers that I'm putting in my matrix. So 2, 3, that's my first row. And in my second equation, you've got 6 and negative 5. Okay, easy. That's the first one. Well, that's the first matrix, which is your number matrix. Second one you've got to put in is your letter matrix. Okay, so let's put that in. Let's see if I use this. I want to use the same colors there, so we're all good. Okay. Second one is the letter matrix. So you can see, okay, in this equation, there's only two unknowns there, x and y. You don't have to put x, y, x, y. That would be wrong. Okay, you just need to put the unknowns in this matrix. So this will tell you how many unknowns they're looking for. In this case, you're just looking for 2, x and y. Okay, and the last matrix is your answer matrix. Okay, which in this case is 4 and 16. Negative 16, sorry. Okay, and there it is. There is the simultaneous equation in matrix form. So you've got your 3 matrices: the number, the letter, and the answer. Okay, let's try it with 3. Okay, so that's question A. Let's try it with 3 equations. Okay, it's the same principle. Yeah, remember, your matrices for the number matrix are going to be in a square matrix form. So Remember, the form has to be A, which is the number matrix, times X, which is the unknown or the letter matrix, and then equals C, which is the answer matrix. All right, let's do this. Okay, so having a look at the equation, all right, familiarize yourself with what's happening there while I do this. Okay, all right, first one. Okay, so let's do the first row, or the first equation there. Okay, so I can see there, you've got X. So remember, in front of every unknown, there's a magic 1 that you don't see. So imaginary 1. So 1. The next one, for the Y, okay, you've got -2. And then for, in front of that Z, okay, there's a +1. That's your first equation. Second one, okay, so we're going to put all the X values in the first column. Yeah, so the X value here is -2. The Y value is +3. Now, there is no Z here, is there, in this equation? So that means in the Z column, okay, we're going to put 0. If you didn't already notice, what these rows and columns represent, so these are your 3 equations, and these are the columns for the letters. Okay, so you've got, the unknowns, sorry. So this is the X column, the Y column, and the Z column. Okay, let's look at the last equation. So there's 2x, so 2 for x. There is no y in this equation, see? So that means for the y column, it's going to be 0. And there's a -1 in front of that z. Remember, in front of every letter that's by itself, there is a 1. Okay, and there is my letter matrix. Easy. Okay, now my number matrix. My letter matrix, I've got 3, x, y, and z. And in my answer matrix, I've also got 3, -2, -3, and 4. And that's how we put equations in matrix form. All right, now let's look into actually solving them. Okay, we've actually already done part of the solving part. It's the same principle as what I remember I taught you guys at the start of this this video. Okay, so let's actually solve this. So using matrix methods to solve, let's solve these simultaneous equations. Okay, so again, these are actually the same, but let's do them again anyway, so we can see how it works. So for A, you're splitting it into 3 matrices. So 2, 3, 6, -5 times. So that's the first matrix. Second matrix is going to be your number matrix equals your answer matrix of 4 and -16. Okay, now what we're trying to do here is we're trying to solve for whatever x and y is. So that means if this is A times x equals C, I have to get rid of this A and bring it over here and pre-multiply it. Okay, so this A, if I multiply it with my A inverse, it's going to cancel itself. Okay, so what's happening now is if I multiply A, now I'll just write it here so that we can see what's happening. So this is matrix A, and I multiply it with 2, 3, 6, -5 with its inverse self. Oops, sorry. Okay, what's going to happen is it's going to cancel itself out. Okay, as in this whole thing is going to be gone. And I've got to do the same on the other side. But remember, it's going to be pre-multiply. Okay, so that A, it's going to be on the left-hand side. So on the other side, okay, it's going to be A inverse multiplied by whatever the answer matrix was, which is 4 and -16. So the inverse, I don't have to calculate the inverse here. I can just literally write A inverse. And that will give me the value for that. So let's do this. So that means let's do this on a calculator. So what is xy? So let's essentially just calculate this on a calculator. Oops. All right. So you've got a square matrix, 2, 3, 6, negative 5. And notice how here I'm not actually going to label it. I'm just going to go straight ahead and put in my calculator. Times 4, so that's that one there, 4 and negative 16. Okay, and what is that? Well, there's my answer. X is negative 1 and Y is 2. Okay, so there's your answer for whatever X and Y is. Now, I can actually test this and put it in these equations. So if X is negative 1 and Y equals negative 2, let's put it in that equation to test it. So 2 times negative 1, and then so let me just rewrite it. Let's put it here. So 2 times negative 1 plus 3 times negative 2 is supposedly 4. Okay. Oh, sorry. Y is 2, because then that wouldn't give me a correct number. Yeah. Sorry. Okay, so let's evaluate that. 2 times 1 is negative 2. Plus 3 times 2 is 6. So negative 2 plus 6 equals 4. Correct. Okay, let's try any other equation. Okay, 6 times, so x is negative 1, minus 5 times 2 is equal to negative 16. So let's evaluate that. 6 times negative 1 gives you negative 6, and negative 5 times 2 gives you negative 10. So negative 6 minus 10 is definitely negative 16. So we got it right. X is negative 1, Y is negative 2. Now, I won't go through B, as it's the same exact process, yeah? So if we were to just look back at what we did here, all you're doing is find the inverse of this, okay, and multiply it, and then in here, multiply the inverse of A with this matrix, and that's all you're doing to find out what X, Y, and Z is. Maybe in the next lesson, we'll go through it together. All right, let's go through this, and then we can take a break and you guys can start working. All right, and then we'll continue on for the rest of this session. So some equations, what you'll find is if you might not have a actual solution to what the unknowns are. And that's because remember when we found the determinant of a matrix, the point of the determinant is it basically tells you if an inverse exists. So if the determinant is 0 for a matrix, that means it does not have an inverse, which means you can't define, or it's an undefined matrix. Okay, and you can't actually find the solution to whatever the unknowns are. Okay, so let's do this. We're not actually going to solve them. We're just going to determine whether a solution exists. And to do that, we're going to, like in the previous chapters, previous things that I went through in the examples, we're turning these matrices into your number matrix, letter matrix, answer matrix. And then in the number matrix, what you're going to do is you're going to find its determinant. And if a determinant exists, that means that you can then do a inverse, which will find the solution. So let's do this. Split this up. So you've got 2x3. Remember these columns, okay, whatever your x and y values are. So 2x, 3y, 5x, and 2 for the y in the second equation. Actually, I'll leave that there. Multiply by x and y, and then here's your answer matrix. Okay, so for this question, all we're doing here is we're going to find and see if this matrix has a determinant. Now, you can probably work it out by hand if you want to. Remember the formula for the determinant is equal to A times D, take away B times C. Remember that's A, oh, sorry to confuse you, that's A, that's D, B, sorry, D, C, D. Okay, I'll change this so it's not too confusing. Times A times D, B times C. Okay, now, again, you can do it by hand, but otherwise you can use your calculator for it. So let's do it by hand here. So the determinant is going to be 2 times 2 So A times D, take away, 3 times 5. Okay, so the determinant in this case is 4 take away 15, which equals -9. So you could say a unique solution, so as an answer, because the determinant, or the determinant of that matrix, is equal to -9. Okay, let's do B. Okay, so same procedure. Let's split this matrix up into its number matrix, letter matrix, answer matrix. So this is going to be a 3 by 3 because there's 3 unknowns that you're looking for. Okay, so that's your x, y, z. And remember, these are your 3 equations. Okay, so for the first equation, there's 2x, there's 1y, and there's 4z. Okay, second equation, there's 3x, there's a -1 for the y, there are no z's. Third equation is 1x, there is 4y, and there's 5z's. And you're looking for x, y, z, and you want 17, -3, and 7. Okay, so all you're doing, again, is you're going to find the determinant of this. Now, because we haven't really given you lessons on how to find the determinant of the matrix that's got a 3 by 3, all you got to do in your calculator is literally type DET 2, 1, 4, 3, 1, 0, -1, sorry. -1, 1, 4, and then 5. Okay, so find the determinant of that in our calculator. Okay, so let's put them in. So you got 2, 1, 4, 3, -1, 0, and 1, 4, and 5. Okay, there's a matrix. So, oh, sorry, I forgot to write. You can actually just type in DET, go up there and highlight that matrix. Okay, and don't forget the bracket. Okay, and the determinant there is 27. Okay, so that means for this equation, okay, a unique solution will exist because the determinant is 27. Okay, all right, we're going to pause it there. I'll get you guys to now work through the questions for 12B, and then we'll come back and we'll do the practical questions as well. All right, so you pause the video and start working, and then when you finish questions 1 to 6, watch the video again for the tutorial on practical questions. Okay, let's do these questions, guys. The application style questions, which in 12B, you're going to need to know how to do for questions 10 and 11. Now, these questions are worth a lot from memory in SACs and exams, so make sure you understand how to do them. All right, let's go through it. On Monday, a cafe sells 90 coffees and 60 teas, giving a revenue of 612. On Tuesday, the same cafe sells 82 coffees, 55 teas, and a revenue of 558.9. Use matrix methods to find the prices of a single coffee and a single tea. Okay, so a couple of things you need to be able to do in this question is understand how to put this into a matrix, or write it into an equation and then transfer that to a matrix, and also figure out what is it that you're looking for. I like to start off by understanding what am I actually trying to look for here. So this second part here tells you what you're looking for. You need to figure out the single price of a coffee and a tea. So we need to find out the individual prices of these unknown variables. So if you look back, or if you've done the previous questions, you'll understand that these two variables can technically be your x and y variable that you're looking for, the unknowns. Okay. Second thing I like to do is look at the question and understand what the numbers are and what my answers are. So remember, the reason why I say that is because you want to try and split your matrix, your equation, into a number matrix, a letter matrix, and an answer matrix. I've already circled or actually worked out here my letter matrices. Now you can find the information here for your number matrix and answer matrix. Now if you look here, these values that I'm circling are the numbers that you're going to put in your number matrix. Okay, and like I said, the coffee and tea are actually your letter matrices. Okay, and so the last matrix that we're going to put in there is our answer matrix, and it's essentially these prices. So if I was going to try and put this into an equation, this is what it's going to look like. Okay, so it's going to be the first equation on Monday. Okay, so let's do Monday's equation. So it's going to be 90x, because it's 90 coffees. I'm going to use x for coffee, plus, I didn't use redstone, plus 60y. Okay, now why did I use 60 and y? Well, because, okay, 60 is the number of teas they sold, and teas are going to be my y variable. Okay, 60y equals, and my answer matrix for, well, the answer for that first day, how much they made on the first day, was $612. So there's my first equation. 90x plus 60y equals 612. Okay, let's repeat the same process for our second equation, because this is a simultaneous equation. So the second one is going to be on the Tuesday, 82 coffees, so 82x. Remember, my coffees are going to be x. Oops, sorry. Okay, and how many teas on the second day? 55. So 55 teas on the second day. Okay, so there, right there is the part of the equation. And the last part is the answer matrix. So how much did they earn on the second day, which is 558.90. Okay, now we've got our two simultaneous equations. We now need to put this into our matrix form. So remember, watch the previous video if you haven't already, so you understand how to do this. But you need to split this up into three matrices. Yeah, so your number matrix, multiply by, your letter matrix, and then equals the answer matrix. Okay, so let's put it in. So in this row, it's this row here, sorry, it's the first equation, and these are your letters, so x and y. Okay, in there, it's that column. So for the first equation, I can see 90 for the x and 60 for the y. Second equation, I can see 82 for the x and 55 for the y. Easy. Now I put in my unknown variables, which is my t. So x, what was it again? I think x was coffee, and y is going to be tea. Cool. And then my answer matrix is 612, and then 558.90. Okay, and so from there, it's pretty straightforward. All we've got to do is find the inverse of this and multiply it with that matrix. Okay, so we're going to inverse this matrix and then multiply it with that matrix. So let me rewrite that for you. X, y equals, multiply there. Okay, so all I'm doing is finding the inverse of this matrix and multiplying it with the answer matrix there. So 612, 558.9. Now, technically, I don't have to evaluate the inverse in here. When it comes to doing the working out, you can literally just type it in as you see in the calculator. So what you're doing here is you're inversing that matrix. So 90, 60, 82, 55 to figure out what x and y are. So remember, it's not just a matter of dividing this matrix by itself. Yeah, you have to inverse it. I'm sorry. you got to inverse it. So you have to multiply it by its inversed self. So 90, 60, 82, 55. Got to multiply it with its inverse self, because what happens is it cancels itself out. And then you got to do the same here. Multiply this by the inverse version of this matrix. Okay, so that means x and y. So let's evaluate this. So remember, we're trying to find the price of one coffee and one tea. So I'm going to use a calculator for this. All right, let's put it in. So I'm literally just going to type this in. So this into my calculator. So nice and easy. 90. Oops, sorry. 60. 82. 55 to the power of -1, because I'm inversing it, yeah? Multiply by, oops, sorry. You cast it to the right, multiply by that matrix there. So the answer matrix. So 612 and 558.9. Now I have to put the 0. So enter, and there is my answer. So for matrix, for the values of x and y, let me fix this up. Okay, so I've got $4.20 for one coffee and $3.90 for a tea. All right, and that's technically all you got to do now. You should write your answer in sentence form, so let's do that. So we can write here for one, that's all, the price of one tea or coffee is $4.20, and one coffee, tea is $3.90. And that's it. Pretty straightforward, I think, with these questions. So just follow the instructions I gave you on how to do these word questions, as they're actually not that hard. You just got to figure out what you're looking for, what are the variables, okay, and what are the numbers that you're working with, and then, you know, what are the answer matrix, what's the answer, sorry, because then you need to put that into an equation, 2 simultaneous equations, sometimes 3, depending on the question. Split that up into your 3 matrices, and then work out your unknowns. Okay, and it's pretty straightforward. If you have any questions, please message me on Teams. Otherwise, go ahead and do questions 10 and 11 in chapter 12b. Thank you.